Okay, Assalamualaikum warahmatullahi wabarakatuh. Thank you for the time. Now I want to explain in this meeting. I want to explain for the material for manufacturing process. The material for this meeting is drilling machine and drilling process. So I hope you will understand what I want to tell you about drilling. So this is the PowerPoint. Next, drilling machine is one of the machine that we use to make a hole of the object in manufacturing process. In our daily, we also can use a drill machine to make a hole in wall or in our house if uh, we want to pass the photo in the wall. In our house, we have portable drilling or drilling with a hand, small drilling type. In this study, I will explain about the type of the drill. The type of the drill that we can use in manufacturing process. This is the introduction. The process of drilling means making a hole in a solid metal piece by using a rotating tool called drill. So this is the picture of a drilling machine. A tool used to drill the holes of different size and other related operation using a drill bit. So we can use make a hole in our workpiece. Example in material baja like this. I have a sample. This is a stainless rod. This is the hole. We can make this hole with a drill machine. The drilling machine is one of the most important machines in a workshop. As regards its importance, it is second only to the lathe machine. So, if we can make a hole, we can use a lathe machine too. So not only with drill machine, we can make a hole with a lathe machine and drill machine. Holes were drilled by the Egyptian in 1200 BC, about 3,000 years ago, by bow drills. The bow drill is the mother of present-day metal cutting drilling machine. This is the construction of drilling machine. In drilling machine is head feed, depth adjustment, spindle clamp, spindle, chuck, regular work table, base table, column, table clamp, motor, belt, wart, and pulley. So the drill is operating with a motor. In drilling machine, holes may be drilled quickly and at a low cost. The hole is generated by the rotating edge of a cutting tool known as the drill, which applies a large force on the work clamp on the table. As the machine uses vertical pressures to originate a hole, it is loosely called a drill press. This is if you want to make a hole, a drilling of a hole. This is the workpiece, and this is a drill. This is a rotary motion of cutting. This is a feed motion, and this is a twist drill. This is the types of drilling machine. We know in our laboratory, we have only one type drilling machine. It maybe we only have a sensitive drilling machine. This is or a pillar type drilling machine, or we can call them basic type of drilling machine. And another the type of drilling machine, and radial drilling machine, multi-spindle drilling machine, and sensitive or bench drilling machine. I will to explain one type to one type. And the first is sensitive drilling machine. Sensitive drilling machine used to drill small holes at high speed in lighter job or workpiece. The machines may be mounted on the bench or floor, and the drilling work is started with the drill fit into the workpiece by purely hand control. So this operation is use hand, so we can control the process with our hand. And the second is pillar type drilling machines. Pillar type drilling machine is the drilling. Sorry. Pillar type drilling machine is these are generally similar to sensitive drilling. So this is a similar about between sensitive drilling and pillar type drilling machines, but are meant for heavier work. If the sensitive drilling machine is used for soft work, that are, and a pillar type drilling machine is used for hard or heavier work. The vertical column can be either of rectangular or round section. The latter offers the advantage that the table can be swung out and the slightly bigger jobs can be accommodated on the machine base instead of the table. The drilling head can be lowered and hole drilled in the job. Next is radial drilling machines. Radial drilling machines is machines that can use to drill holes in bigger and heavier workpiece. So this is for a bigger workpiece and heavier workpiece, which cannot be manipulated so that the center of the hole may be aligned with the drilling spindle. In this case, the drilling head is mounted on a radial arm. The radial arm can be rotated around the round column, and the drilling head can be moved in or out on the radial arm. So this drilling machine has a arm. The arm used to rotate around the round column and move in out. The next is multi-spindle drilling machines. On these machines, more than one hole may be drilled at one time. These machines are very useful for mass production work. So if we want to drill some workpiece at one time, we can use multiple spindle drilling machine. The in multi-spindle, the spindle is more than one. So the drill is more than one too. So we can make a hole in some workpiece. This is the picture of the type of drilling. This is the picture for sensitive or bench drilling machines. They have a spindle, chuck, drill, table clamp, base, drill fit handle. Drill fit handle that we use our hand to operation drill machines. This is the pulleys and motor. This is the radial drilling machines. They have a column, elevating screw, table, base, spindle drill, a fit hand wheel, drill head, motor for spindle, radial arm, motor for elevating screw. If insensitive only have one motor, then the radial drilling has two motors. The motors for elevating screw and motor for spindle. Then the spindle has a motor too. The next is common operation closely associated with drilling. This is a core drilling, step drilling, contour boring, and contour seeking. This is the operation. The core drilling holes made in casting by use of cores are rough and require a special kind of drill called core drill to clean up the holes. This operation is called core drilling. Next, the step drilling. In the step drilling, more than one diameter can be ground on the drill body, which serves an extra operation. Then a contour boring. In contour boring, often a flat surface is needed around a hole to provide a good sitting area for washer and nuts or head of a bolt. The contour boring tool has a pillow, which ensures that the contour bore is concentric with the hole. Then the contour sinking. Contour sinking provides a tap entrance to the hole. A special contour sinking tool with a pilot is used as shown in this figure. This is the common operation or the basic operation that we can operate them in drilling machines. This is the types of drills. We know the three types of drills. The first one is flat drill. The second one is straight foot drill. And the third is twist drill. I will explain it. Flat drill is usually made from a piece of round steel, which is forged to shape and ground to size, then hardened and tempered. The cutting angle is usually 90 degrees, and the relief or clearance at the cutting edge is 3 to 8 degrees. The disadvantage of this type of drill is that each time the drill is ground, the diameter is reduced. Twist drill is the most common. This is the twist drill is the most common type of drill in use today. So, in our manufacturing process, the basic drills that we must use are a twist drill. In our laboratory too, we also use a twist drill. For flat drill and straight foot drill is not common types of drill that we can use. This is the types of twist drill. The twist drill for parallel shank type and more taper shank type. Next is number and letter size. number size, in metric system, the drill is generally manufactured from 0.2 to 100 millimeter. In British system, the drill size ranges from number 1 to number XT. Number XT is the smallest having diameter equal to 0.0135 inch, and the number 1 is the largest having diameter equal to 0.228 inch. Number 1 to number 60 is the standard set of drills. The numbers is 60 to 80 size drills are not so commonly used. So the commonly used is number 1 to number 60. The diameter of drills increase in steps of approximately by 0.002 inch. The next is letter size. The drill size ranges from A to Z. A being the smallest having diameter equal to 0.234 inch, and Z being the largest having diameter equal to 0.413 inch. Increasing in step of approximately 0.010 inch fractional size. The drill size ranges from 1/64 inch to 5 inch in from A to Z. So, from A to B, the range is from 1/64 inch to 5 inch. A being the smallest having diameter equal to 0.234 inch, and Z being the largest having diameter equal to 0.413 inch, increasing in step of approximately 0.010 inch fractional size. And the drill size range for 1/64 inch to 5 inch in step of 1/64 inch up to 1.75 inch. Then the steps gradually increase. The drill is generally removed by tapping a wet shape strip into the slot in the drilling machine spindle. I don't have a picture of removing a drill from drill machines. The next is twist drill geometry. The twist drill geometry and its nomenclature. This is the figure of nomenclature of standard general purpose twist drill. A twist drill has 3 principal parts. The first one is drill point or dead center. The second one is body. And the third is, or the last is shank. The first is drill point or dead center. This is the body, and this is the shank. This is the overall length. From shank until length, this is the overall length. Drill axis. Drill axis is the longitudinal center line. Drill point in drill has a drill point. Drill point is the sharp end of the drill body, consisting of all that part with its shapes to produce lips, face, and chisel edge. Lip or cutting edge is the edge formed by the intersection of the flank and face. Lip length is the minimum distance between the outer corner and the chisel corner of the lip. Then this is a heel, length, helix angle, flute, body clearance, width of helix. This is the body diameter clearance. This is the lip length. This is the lips. And another, you can short the function of each part. So I hope you can search in Google on manufacturer process book. What is the function of each part? I will not explain all of function. I will explain one by one, but in example, only in example. The function of, for example, the function of body clearance. This is the body clearance. Is that portion of the body surface reduced in diameter to provide diametric clearance. Then the function of helix angle. Helix angle is the angle between the leading edge of the land and the drill axis. Okay, next, drill material. Drills are made out of high-speed steel. High-speed steel is used for about 90% of all twist drills. For metal more difficult to cut, HSS alloys of high cobalt series are used. So, if our workpiece is more difficult to cut with steel material, we can use HSS or HSS alloys of high cobalt series. This is the example of a drill. Next is operation performed on drilling machines. In drilling machine, we can make operation for drilling, reaming, boring, counter boring, counter sinking, spot facing, tapping, lapping, grinding, and trepanning. What is that? Reaming. First one is drilling operation. This is the figure of drilling operation. This is the operation of making a circular hole by removing a volume of metal from the job by a rotating cutting tool called drill. Now, this is we rotate the drill so the workpiece has a hole. Drilling removes solid metal from the job to produce a circular hole. A suitable drill is held in the drill machine, and the drill machine is adjusted to operate at the correct cutting speed. The drill machine is started and the drill starts rotating. Cutting fluid is made to flow liberally and the cut is started. So if we operate the drill, we must use oil to lubricate the drill and the workpiece. The hole, depending upon its length, may be drilled in one or more steps. After the drilling operation is complete, the drill is removed from the hole and the power is turned off. So if we want a hole with some diameter, for example, we want to 10 diameter, so we operate the workpiece in drill machines step by steps. So we will, for example, we drill in for the first we drill in 4 millimeters. For next we in 7 millimeters until 10 millimeters. Next is reaming operation. This is the operation of sizing and finishing a hole already made by a drill. So when the object done in drilling first process, so the next is reaming operation. Sorry. Reaming is performed by means of a cutting tool called reamer. Reaming operation serves to make the hole smooth. So if the first operation drilling, the workpiece is kasar or not smooth, then the next operation is in reaming operation. Reaming operation is used to make our workpiece more smooth. A reaming operation is performed by means of a multi-tool tool called reamer. Reamer possesses several cutting edges on outer periphery and may be classified as solid reamer and adjustable reamer. The next is boring operation. In boring operation, a hole by means of adjustable cutting tools with only one cutting edge is completed. A boring tool is employed for this purpose. This is the figure on the picture of a boring operation. This is, we have a workpiece. This is the feed direction, tool rotation, boring head, and boring tool. Next is counter boring operation. Counter boring operation is the operation of enlarging the end of a hole cylindrically. As for the resist for a countersunk reef, the tool used is known as counterbore. Next is countersinking operation. Countersinking operation is the operation of making a cone shape. This is a cone, like a cone. This is cone. Enlargement of the end of a hole. As for the resist for a flat head screw, this is done for providing a seat for countersunk heads of the screws so that the latter may flush with the main surface of the work. So for the first view, we have a box piece with a hole, but in the bottom, we want to make a cone model, so we can use a countersinking operation. Next is slapping operation. This is the operation of sizing and finishing a hole by removing very small amounts of material by means of an abrasive. So the abrasive material is kept in contact with the side of a hole that is to be lapped by the use of a lapping tool. Next is spot facing operation. This is the operation of removing enough material to provide a flat surface around a hole to accommodate the head of a bolt or a nut. A spot facing tool is very nearly similar to the counterbore. This is an operation is like a counterbore, is similar. Next is tapping operation. It is the operation of cutting internal threads by using a tool called a tape. A tap is similar to a bolt with accurate threads cut on it. To performing the tapping operation, a tap is screwed into the hole by hand or by machine. So we can tap with machine or manual by our hand. The tap removes metal and cuts internal thread, which will fit into external thread of the same size. For all materials, except cast iron, a little lubricant oil is applied to improve the action. So if we do a tap operation, we must use oil to lubricate to our workpiece. This is for small. If we use oil, we can more than easy to tap a workpiece. The tap is not turned continuously, but after every half turn, it should be reversed cyclically to clear the threads. This is the geometry and nomenclature of tap. In next explanation or next video, I will give some video or simulation about drilling. This is the core drilling operation. Core drilling operation is a main operation which is performed on radial drilling machine for producing a circular hole which is dipped in the solid metal by means of revolving tool called drill. This is the common drilling process. Next is size of drilling machines. In drilling machines, different parameters are being considered for different types of drilling machine to determine their size. The size of a portable drilling machine is decided by the maximum diameter machines. The size of a portable drilling machine is decided by the maximum diameter of the drill that it can hold. The sensitive and upright drilling machines are specified by the diameter of the largest workpiece, which can be centered under the drill machine spindle. A radial drilling machine is specified by the length of the arm and the diameter of the column. To specify a drilling machine completely, following other parameters may also be needed to specific drilling machine. When we use a drill machine type A, type B, and extra, may also be needed to know table diameter, number of spindle speed and fits available, maximum spindle travel, more step per number of the drill spindle, power input, net width of the machine, and floor space required. So this is the size of a drilling machine. For drilling machine type A and drilling machine type B has a different size. For example, table diameter in drilling machine A is not same with a drilling machine B. For example, if like that. So next is in drilling operation, we can calculate cutting speed and feet. So the number on the value of cutting speed, we can calculate them with this equation. For cutting speed, or CS equal to 22 per 7 where D is the diameter of the drill in millimeter, and S is the N is the RPM of the drill spindle. Next, feet. Feet, the equation for feet is F equal to FR multiple by N, where FR is feet per revolution in millimeter, and is RPM of the drill. This is the operation, and I will to explain the calculation, some of example of drilling operation calculation in the next video. Thank you for your attention, and I hope you want to share more reference of a drilling machine, so you can know about drilling machine with more than 4 hours, more than my explanation. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.